दिसतंय का बघा स्क्रीन यूट्यूबवरती यूट्यूब किंवा जरा चेक करा. दिसतंय? Good morning, everyone. Sorry, good afternoon. Let's start with the next lecture of control system design. In previous chapter, we have started with the controller design by transformation. That is, prior to that, this controller design by transformation, we have also seen the controller design for phase variable form of system. I mean, the system which are represented in a phase variable form. For that, you can use the matching coefficient method. Just you need to compare two equations, actually, and the characteristic equation. You will come to know the value of feedback gains, right? Now, what if the system is not represented in a phase variable form? I mean, any other form, cascade form, control canonical form, or observer canonical form, parallel form, etc. Then for that, we need to use second method, that is controller design by transformation method, right? So in transformation method, we have seen in previous lecture also. What we are going to do is take a system which is not represented in a phase variable form. First of all, transform it into phase variable form. Then design the controller and again finally retransform back to its original form. Right? So for that we need a definite relationship between the plant which is not represented in phase variable form and the plant which is represented in a phase variable form. That we denoted by the transformation matrix. That is capital P. We have seen that. Let's have a see. Initially, we have seen they assume that the plant which is not represented in a phase variable form or not represented in phase variable form, we assume the notation as a z, and for phase variable form it is x. Okay, you can see here two equations: z dot equal to az plus bu, y equal to cz plus du. These are represented in a non-phase variable form. Okay, this is the first step, representing non-phase variable form. Second step is to find the its controllability matrix, that is CMZ. Okay, then next transform the given matrix, given system into uh, phase variable form using that relationship z is equal to p into x. Okay. Then once you represent in a phase variable form, then calculate its controllability matrix, that is we normally denote it by CMX. Right? Now once you know the controllability matrix in both form, that is in non-phase variable and in phase variable, that is CMZ and then CMX, you can easily find the transformation matrix, that is capital P. Right? We have seen already this. Let's start with the designing steps via transformation method. You can see here. First of all, you need to find the state and output equation of the plant which is not represented in phase variable form. I mean, you need to use the notation Z. Okay, you can see here. Find the state equation and a controllability matrix in the form of system represented. काही कुठल्याही फॉर्म मध्ये असू शकेल, cascade, parallel, anything. Okay, so you need to write state and the output equation for that. You can see z dot is equal to az z plus bzu. Remember that notation z indicates it is in non-phase variable form. This matrix az is a system matrix which is represented in a non-phase variable form. Right? For phase variable form, I am going to use a to the base x. Right? You need to write the state in the output equation and then need to find the controllability matrix, that is CMZ. Remember these steps. Based on these steps, we are going to see one or two numerical. Once you calculate the controllability matrix, you need to verify whether that system is controllable or not. Right? If it is controllable, then and then only it is advantageous to design the controller. करेक्ट ना. समजा एक कुठला प्लांट आहे, कुठला तरी एक प्लांट आहे, तो कंट्रोलेबलच नाही आहे, तुम्ही कंट्रोलर डिझाईन तरी करून काय उपयोग आहे. गेटिंग मी. So first of all, you need to cross verify that given system is controllable or not. कळत आहे. आणि ॲज फार ॲज थेरी इज पॉसिबल, थेरी इज कन्सर्न, थेरीमध्ये ऑब्व्हियसली तुम्हाला 10 मार्क देणार या न्यूमरिकलचे. तुम्हाला काय वाटतं, सिस्टम जे कंट्रोलेबल नाही आहेत त्यांना कंट्रोलर डिझाईन करायला न्यूमरिकल देतील का तुम्हाला? नाहीतर तुम्ही पहिल्या स्टेपमध्ये लिहून टाकाल, ॲज सिस्टम इज नॉट कंट्रोलेबल सो इट इज नॉट पॉसिबल टू डिझाईन द कंट्रोलर. 10 मार्क असंच द्यायचं का? नाही. सो ऑब्व्हियसली all given numericals or systems are controllable. तसलेच न्यूमरिकल तुम्हाला फायनल एक्झाममध्ये येतील. सो चेक इट्स कंट्रोलॅबिलिटी मॅट्रिक्स. इफ येस देन ओनली प्रोसीड टू नेक्स्ट स्टेप. इफ इट इज अनकंट्रोलेबल यू नीड टू स्टॉप दॅट. असले न्यूमरिकल येणार नाहीत. Now represent the given system in a phase variable form. How to represent in a phase variable form? First two rows are constant value in a phase variable form, 0 1 0 0 0 1, right? And last row represents the denominator of transfer function. And just check out in numerator whether it is constant term or whether it is a phase variable form. Accordingly B and C matrix will change. Correct? So you need to represent the given plant into phase variable form. Now you can see I have represented or I have written the static and output equation. X dot is equal to a to the base बघा काय. Here it is x. Why? Because I am representing in a phase variable form. Right? Once you represent or write state and output equation, then again you need to find its controllability matrix, that is CMX. B square b up to a raised to n minus 1b. Right? काय केलं तुम्ही आता आतापर्यंत अप टू दिस स्टेप, थ्री स्टेप, you have written the state and output equation for both phase variable, non-phase variable, and you have calculated the controllability matrix for both, that is phase variable form and then non-phase variable form. इथपर्यंत केलं तुम्ही. Next step is to find the transformation matrix, that is capital P. Capital P can be given by, we have already derived this equation, P is equal to CMZ into CMX inverse in last lecture. कुठनं आला प्लीज विचारू नका, तुम्हाला लक्षात नसेल, मला लक्षात आहे. P is equal to CMZ into CMX inverse. Once you calculate the transformation matrix, now you will start to design the controller in a phase variable form. Still you are in a phase variable form. You need to design the controller, right? For that you need two equation. One is a actual equation, second is a desired characteristic equation. Then you will compare those two, you will come to know feedback gains presented in a phase variable form. Finally we are going to convert in a its original form. Getting me? So you need to calculate the desired characteristic equation. Desired characteristic equation is given by what? S square plus 2 zeta omega ns plus omega n square. This is standard second order system characteristic equation. Now to calculate this you need zeta and omega n. Right? So in a numerical he will mention you design a controller to yield overshoot of this percent or a settling time of this second वगैरह. Overshoot, settling time or peak time is given to you. From that you need to calculate value of zeta and omega n. Once you know that, calculate this value, s square plus 2 zeta omega ns plus omega n square. ठीक है, हे मिळालं. You can see here highest power of s is just 2, means what? This is still a second order characteristic equation, right? Suppose the given system is of third order, then you cannot compare those two equations. म्हणून you need to select the third extra closed loop pole such that there will be pole zero cancellation takes place. That's why I am selecting here. You can see third closed loop pole which cancel the closed loop zero. Right? Now you need to find the actual characteristic equation given by determinant of Si minus Ax minus Bx into Kx. I am designing the controller now in a phase variable form. Right? So you have Ax matrix, Bx, and then let Kx matrix is K1, K2, K3. Right? By comparing you will come to know values of K1, K2, K3. In a phase variable form. So instead of writing just only K1, K2, K3, I will write K1x, K2x, K3x. These are the gains in a phase variable form. Right? You can see. Find Kx matrix by comparing desired and actual characteristic equation. And now finally transform back to its original form by using this relation Kz is equal to Kx into P inverse. Now what is the difference between Kz and Kx? x मी सांगतो, एक तुम्ही सांगा. kx are the gains represented in a phase variable form. Now kz are the gains which are represented in non-phase variable form, that is its original form, right? एवढं जरी केलं up to step number 8, that is more than enough, you will get 10 marks. स्टेप नंबर पुढे 9 10 वगैरे काय गरज नाही आहे तुमच्यासाठी. Getting me? So based on that, let's start with the first numerical. Please write it. What you say? Design a state variable feedback controller. See, read the numerical very carefully. तर आणि तरच तुम्हाला कळेल whether to use matching coefficient method or transformation method. Okay? He said that design a state variable feedback controller. Okay, I'll design a controller. He's saying design a controller. अजून एक पुढे येईल observer. हे आधी नीट वाचायचं. He's saying design a controller. I need to design controller here. To yield, we are given overshoot is not. Normally denoted by percent MP, which is given 20.8% overshoot. From this, you can easily calculate value of zeta. Right? मी बोलायचं पण बोलतो easily calculate, पण तुमच्यासाठी अवघड आहे ते, I know. Then he is saying that settling time must be 4 seconds. Settling time is given 4 seconds. I know normal settling time is not 4 upon zeta omega n. You have already calculated zeta. You know settling time, you know zeta, you can easily calculate value of omega n. Okay? Next, what he said for the plant is given g of s is equal to s plus 4 divided by s plus 1 to 5. These are the given open loop plant. You can design a controller to achieve 20.8 overshoot and then settling time of 4 seconds. या प्लांट से किती ओवरशूट है, किती सेटलिंग टाइम है, आई डोंट नो, मला माहिती नाही. I need to design a controller just to achieve this specification from this plant. ठीक है? And also say that खालचा एक शब्द वाचा नीट. This plant is represented in we say cascade form. In short, cascade is a non-phase variable form. Right now, phase variable असता तर easily मी matching coefficient method वापरला असता. But he's saying this plant is represented in a cascade form and figure is given. तुमच्यासाठी चांगला आहे, figure is given here. Right? So first of all, I need to represent this plant in a cascade form by writing the equation to that figure. Getting me? Now, why I am going through transformation method? Why not by a matching coefficient method? Because plant is represented in cascade form, which is not in a phase variable form. That is the reason I am going with the method number 2, that is by transformation method. Controller designed by transformation method. Okay? So let's just write the state and output equation for the plant which is represented in a cascade form, which is given by z dot is equal to az into z. जैसे लिखा ना ax plus bu, कसं होतं? az into z plus bz into u and y is equal to cz into z. Most of the time, feed power matrix, that is D matrix, is a 0. Right? Okay? Now I need to write the equation for C, I need to calculate matrices AZ, BZ and then CZ. ठीक है? So कसं लिहिणार मी? माझ्यासाठी चांगली गोष्ट आहे. He has already given me a state model, right? So from this state model, just tell me the equation for Z1 dot, Z2 dot and then Z3 dot. Z1 dot. Here is the Z1 dot. Just check incoming. Z1 dot is equal to incoming bar load length, incoming signals. This one times of Z2, then minus 5 times of Z1. Correct? So 1 times of Z2 minus 5 times of Z1. Right? Similarly, tell me equation for Z2 dot. Z2 dot is here. Z2 dot is equal to 1 times of Z3 minus 2 times of Z2. Right? Now last one for the Z3 dot, U 1 times of U, and then input minus Z3. That's it. Right now? Now what about output? Y. Output Y. This one. Incoming bar 4 times of Z1 and then 1 times of Z1 dot. Right? And write it 4 times of Z1 and 1 times of Z1 dot. Right now? But Z1 dot is what? Z2 minus 5 Z1. Just I replace it plus Z2 minus 5 times of Z1. 4 Z1 minus 5 Z1. Total 3 minus Z1. This is the equation for output Y. Right? Now we'll write the state in the output equation. Z dot is equal to, as system is of third order system, if you multiply inside the bracket s plus 1, s plus 2, s plus 5, highest power of s कितनी 3 है, s cube है. So system is of third order. So matrix A will also be a 3 by 3 matrix and 3 state variables, Z1 dot, Z2 dot, and then Z3 dot. Right? So Z1 dot, Z2 dot, Z3 dot is equal to, I'm writing state equation. Z dot is equal to matrix A Z, right? This is what my matrix A Z into Z. Z कितने 3 है. Z1, Z2, Z3 plus matrix B Z into U. Right? So y is equal to minus Z1 plus get it? Now similarly, output equation Y can be written as CZ matrix, I don't know, CZ matrix into Z, there are 3 Z and 1 Z. Fine? Now take an equation of Z1. Z1 is equal to minus 5 times of Z1, 1 times of Z2. Just tell me the coefficients here. Z1 dot is equal to minus 5 times of Z1, 1 times of Z2, 0 times of Z3. ये क्या coefficient है ये? Minus 5 times of Z1, 1 times of Z2, 0 times of Z3. What about U? Plus U term is Z1 dot per the 0 into U. Correct? Now Z2 dot, just tell me the coefficients. 0, 0 Correct? Remember, this is AZ matrix, this is BZ matrix. Now finally, take equation of Y, just take the coefficient of C matrix. Minus 1 times of Z1, 1 times of Z2, 0 times of Z. Correct? Now next step is to find, let's say 1. Step 2, you need to find controllability matrix. Controllability matrix, that is CMZ. You are still in a non-phase variable form. CMZ. Adi baguya. The given plant is controllable or not. Then and then only we will proceed. Okay. CMZ is equal to, normally it is given by B, AB, A square B up to A raised to n minus 1 into B. Right? As still we are in a non-phase variable form, that is in cascade form. So instead of B, I write BZ, AZ BZ, AZ square BZ, BZ raised to n minus 1 into BZ. Right? The value of n is the order of system. Order ki diya? Third order system. So there is 3 minus 1. Kiti? 2. So that's why this controllability matrix will run up to AZ square into BZ. That is 2 is n minus 1, 3 minus 1. Right? So you have a CMZ is equal to, you have BZ matrix 0, 0, 1. This is what BZ matrix. Just take it 0, 0, 1. Now take your calculator, do this one. AZ into BZ. Here is the AZ matrix, here is the BZ matrix. In last lecture, we have seen how to multiply matrices. Calculator. Now, at least in this lecture, you can directly write CMZ matrix. Another very correct question. CMZ matrix is a 0, 0, 1. AZ into BZ is a 0, 1, minus 1. AZ square into BZ is 1, minus 3, 1. Okay? And obviously, the decrement of this CMZ matrix will be non-zero number, so it is controllable. Okay, the determinant is a -1. Determinant of the CMZ matrix is a -1, as it is non-zero number, so it is controllable. Then yes, as it is controllable, we can proceed to next step. Hello? Now, as of now, we are represented in a cascade form, that is non-phase variable form. That's why we have used the notation as a check. Now, let's represent the given system in a phase variable form. Phase variable form of the so far. And this can, for this phase variable form, I can write the equation as x dot is equal to axx plus bxu and y is equal to cx into x. Right? जिथे z होता तिथे x घेतला because I am in phase variable form. Okay? Now from this, again as system is of third order system, that's why there are three derivative of state vectors. There is x1 dot, x2 dot, x3 dot is equal to matrix Ax, I don't know value, into x plus matrix B into x. Okay? Now in a phase variable form, I need this transfer function only. S plus 4 divided by s plus 1 to 5. Just multiply this inside the bracket. S plus 1, s plus 2, s plus 5 inside the bracket, multiply that. Just tell me a polynomial equation. And that polynomial equation is given there. S cube plus 8s square plus 17s plus 10. This is what my polynomial equation after multiplying inside the bracket. Now I can easily write in a phase variable form. I know that first two rows of a matrix in a phase variable form are constant to value 0, 1, 0, 0, 0, 1. Right? Only third row represents the denominator in a reverse order with a negative sign. Constant term है एक डे रिफ्लेक्ट करा with a negative sign -10. S term -17 and then -8. This completes A matrix. Now B matrix and C matrix, just check out numerator ला कौन है, constant term है कि polynomial क्या है? Numerator ला constant term है कि polynomial term है? Polynomial term, right? Polynomial here, there is a polynomial term in the numerator, then B matrix will be a constant to value 0, 0, 1. And then these coefficients will reflect in a C matrix in a reverse order with the same sign. That is here 4, S1 term 1, S2 term is absent, S1 is 0 or 1, 0. This is represented in a phase variable form. Correct? Now next step is to find its controllability matrix. Again, system is of third order, so controllability matrix in a phase variable form will be CMX is equal to Bx ax bx ax square into bx. Why x? Because I'm in phase variable. Right? We have a bx matrix which is 0, 0, 1, 0, 0, 1. Calculate ax into bx, then ax square into bx. That comes out to be 0, 1 minus 8, then 1 minus 8, what is 7? परत आता डिटर्मिनंट काढायची गरज नाही होती. परत चेक करायची गरज नाही हे कंट्रोलेबल आहे की नाही. एकदा केलं ना कळलं इट इज अ कंट्रोलेबल. परत सारखं सारखं चेक करायची काही गरज नाही. राईट. So once you get that CMX matrix, now you need to find the definite relationship between cascade form and then phase variable form. That relationship is given by transformation matrix, that is capital P, given by CM Z into CMX inverse. We have CM Z आत्ताच काढलं होतं. Here is a CMX. Take inverse of that CM Z and multiply it with CM Z into CMX as an inverse gap. Then we will get transformation matrix. So this is what it is take number 6, 5. Step number 5 is to find transformation matrix. P is given by CMZ into CMX inverse. CMZ काढलेलं CMX इथे आहे. We can easily calculate capital P. कसं काढायचं माहिती आहे? हे दोन्ही मॅट्रिक्स सेव्ह करून घ्यायचं कॅल्क्युलेटर मध्ये. CMZ घ्यायचं आणि CMX चा इन्व्हर्स घ्यायचा. इन्व्हर्स तिकडे आहे ऑप्शन INB ऑफ A किंवा रेस टू -1 करा. We'll get a transformation matrix. That is, here it is 1.10, then 0, 1, 7, 0, 0, 1. This is your transformation matrix. So remember one thing, your paper is or your final exam is offline. त्यामुळे गुगल किंवा कुठले नोट्स तुमच्या कामी येणार नाही. समोर टीचर असेल. सो तेव्हा विचारत बसू नका डाऊट सर हाऊ टू कॅल्क्युलेट इन्व्हर्स इन कॅल्क्युलेटर वगैरे. स्टिल यू हॅव टाइम. आय थिंक अजून 1 महिना बाकी आहे. आत्ताच चालू आहे. So once you calculate that capital matrix, capital P, next step is to find or is to design the controller now. For to design a controller, I need 2 equations. One is a desired characteristic equation, second is the actual characteristic equation, right? So desired characteristic equation is given by step number 6. Desired characteristic equation is given by third pole multiplied by s square plus 2 zeta omega n s plus omega n square, right? Which is equal to, where to select third closed loop pole? गरज आहे का आधी? Yes, here it is, because system is third order. फक्त एवढंच घेतलं तर सेकंड ऑर्डर होईल. हे नाही घेतलं तर सेकंड ऑर्डर होईल. कंपेअर नाही करता येणार. Getting me? So I need to select the third closed loop pole such that there will be pole 0 cancellation takes place. इथे बस सिस्टम मध्ये 0 कुठे आहे? s equal to -4 ला, त्यामुळे पोल सिलेक्ट करा s equal to -4 so that pole आणि 0 cancel out होतील. So you need to select the third closed loop pole at s plus 4. Right? Multiplied by s square plus, just calculate value of zeta and then omega n from a given overshoot and settling time. Zeta comes out to be 0.447 and omega n is a 2.24 radian per second. From those values, I can multiply which the omega n comes out to be 2s plus 5, which is equal to 0. This is what my design characteristic equation. Multiply these two, comes out to be s cube plus 6s square plus 13s plus 20 is equal to 0. This is my desired characteristic equation. Let this is equation number 1. आता आहे तसं लिहून घेऊ नका, समजून घ्या. Now next step is to find actual characteristic equation which is given by determinant of Si minus Ax minus Bx into Ax. Why X? Because still I am designing a controller in a phase variable form. नंतर मग त्याला मी original form that is in cascade मध्ये convert करतो. शेवटी this is equation number 1, that is desired characteristic equation. You have Ax matrix, Bx matrix, Kx, take it as a K1x, K2x, K3x. So instead of directly finding determinant of Si minus something, I initially find only this matrix, take Si minus subtract करें, then I finally calculate its determinant. Okay? So I need to calculate here initially Ax minus Bx into Qx. Okay? Ax matrix was 0, 1, 0, 0, 0, 1. Suddenly Ax matrix minus 10 minus 7 17. This was your Ax matrix, minus Bx matrix, which is constant value 0, 0, 1, and Kx matrix is a K1x, K2x, K3x. Okay? When you multiply these two matrices, obviously 0, 0, 0, 0, 0, 0, K1x, K2x, K3x. Right? So I'll write it. जर सबट्रॅक्ट करता यायलाच पाहिजे. येईल ना? 0 minus 0, 1 minus 0, 0 minus 0. खरं आन्सर कुठलं पाणी कुठल्या फॅकल्टीकडे जातो. Right? Only the change is in this row. This row will be minus 10 minus K1x, minus 17 minus K2x, minus 8 minus K3x. Right? Only this will change. take minus sign outside the bracket. 10 plus k1x, there it is. 17 plus k2x, and third is 8, 8 plus this is what your ax minus bx into kx minus. Okay? And now you need to find si minus ax minus bx bx into kx. Si मतलब एक subtract करायचं. S into I is an identity matrix. SI matrix काय आहे? Identity matrix ला तुम्ही S ने multiply करायचं. The same diagonally S येतील ना? Right? So I'll write here Si minus ax minus bx into kx is equal to, I'll write here Si minus Si matrix S 0 0 0 S 0 0 0 S. This is what Si matrix. Right? We need to subtract this one. Now we subtract another. This S will get reflected here. S minus 0 is S. 0 0 7 0 S. Here it will be S. Right? And this method 0 7. Same right now. Only there is a change. This will be S minus minus. So S plus K3X. Right? This is what my Si minus Ax minus Bx Ax minus. Okay? Now you need to find its determinant. अरे multiply करा नंतर नहीं आणि multiply केल्यानंतर 0 होईल सगळं. Okay. So determinant of Si minus Ax minus Bx into Kx is S cube plus, see, Si minus Ax minus Bx, then the final determinant is this one. S cube plus, you can cross verify, 8 plus K3X S square plus 17 plus K2X and plus K1X. That is my equation number 2. This is what my desired characteristic, sorry, actual characteristic equation. Correct? Now you need to compare desired characteristic equation and then actual characteristic equation. Just tell me values of K1X, K2X and then K3X. Compare the equation 1 and equation 2. By comparing, just tell me this term 8 plus K3X is equal to आता बघा एक्सपर्ट किती डिजायर्ड कॅरेक्टरिस्टिक इक्वेशनचा एक्सपर्ट किती आहे 6 8 plus कितनी x equals 6 x वाला टर्म किती आहे 13 constant term right from this k3x is equal to 6 minus 8 right किती 13 minus 17 minus correct these are the values of k1 k2 and k3x आता हे व्हॅल्यू कशात आहे फेज व्हेरिएबल की नॉन फेज व्हेरिएबल फेज व्हेरिएबल कारण x आहे अजून यांना त्यांच्या ओरिजिनल फॉर्म मध्ये कन्वर्ट करायचं ओरिजिनल फॉर्म मध्ये काय असतील रेंज व्हॅल्यू k1z k2z k3z बरोबर ना तर एस काय kz मॅट्रिक्स आहे kx मॅट्रिक्स म्हणला kz is equal to kz मॅट्रिक्स डिराइव केला होता ना मागच्या लेक्चरला kz is equal to kx into p inverse right kx matrix is a kx matrix 10 minus 4 minus 2 we have p matrix as the inverse here we will get k3 matrix sorry kz matrix see you will get kz matrix for value minus 20 out of this is kz1 kz2 छेड आहे in short is in its original form that is in this case it is a cascade form पुढचे स्टेप नाही केला तरी हरकत नाही या मार्गासाठी एवढंच बस any doubt लिहून फक्त लिहून घ्यायला काय डाऊट लागतं असं clear okay next lecture we'll start with one more example simple example बा तुम्हाला हे घरी करता आलं तर उत्तम आहे नाहीतर आपण नेक्स्ट लेक्चर मध्ये कंटिन्यू करूया just write down the numerical open loop plant is given g of s is given 100 into s plus 2 s plus 20 खूप सिंपल है मासाठी 100 into s plus 2 s plus 20 d of s plus 134 design a controller to yield still is saying design a controller okay आणि अजूनपर्यंत आपण डिसाइड नाही केला whether we should go with the matching coefficient method or transformation method ते शेवटी डिसाइड करूया पण आता तत्पुरता एवढं कळालं की we need to design a controller to yield 15% overshoot and peak time of 0.5 second peak time दिलेला था फॉर्म्युला चेंज होईल सेटिंग टाइमचा आणि सेटिंग टाइम 4 upon zeta omega peak time pi upon omega d Omega d is equal to omega n under root 1 minus zeta square. From that you can easily calculate omega n. He said that finally, आता वेळ आली आहे whether to go with the matching coefficient method or transformation. He said that use the असं काय दिसेल use the controller canonical form which is not in phase variable form. Controller canonical form मध्ये हा system represent केलेला आहे. So that is the reason we need to go with which method? By matching coefficient or by transformation? By transformation method. Control canonical form for the state variable feedback. Okay. In next lecture, just try to represent this given plant into control canonical form. Control canonical form मध्ये कसं represent करतात आधी ते माहिती पाहिजे. ते आज वाचून घ्या. Then we'll proceed with the new. Right? Yeah, online students, any doubt? पास है